In this video, we're going to learn how to find the area bounded by a polar curve designed for AP Calc BC or AP Calc AB. So first, the formula for this is A for area is 1/2 integrated from alpha to beta of f of theta squared d theta. Now, what you need to understand is that f of theta, if we're talking in polar, is the same thing as r, because when you write r equals something, it's the same thing as saying f of theta equals something. So this is your formula, and if we simplify it, we're going to get the 1/2 from theta 1 to theta 2, that's how I'm going to be referring to it in this video, is equal to r squared d theta. So before we begin, there are two kind of helpful formulas that we're going to use a lot in this, and the first one is that sine squared theta is equal to 1 minus cosine 2 theta over 2, and the second one is cosine squared theta, is equal to 1 plus cosine 2 theta divided by 2. These are two very helpful formulas because often when you integrate, you're going to end up, if the r is, say, like r equals sine theta, when you square it, you're going to have sine squared theta. It's often way more helpful than doing the power rule and then some trig integration to just convert it to this. So we're going to start off by doing just a simple problem, and that is going to be r equals 6 sine theta. Okay, so if we're going to graph this, it's going to be not exactly the best graph, but 6 sine theta, you're going to have positive, so you know it's going to be in the top half of the graph, and it's going to have a diameter of 6. It's k equals 6, a radius of 3. I'm going to put our 6 right there. That is, that's kind of what your graph is going to look like. And we want to find the area bounded by this region. So that means we're talking about all of that. Now, there's two ways you could approach this. Remember that we have A equals 1/2 r squared from theta 1, or excuse me, we can put the 1/2 outside. 1/2 theta 1 to theta 2, r squared d theta. Now, before we even begin the problem, we need to understand what theta 1 and theta 2, what are we going to set that as? So you know that this is 0, pi over 2, and pi. If you've learned this in pre-calculus, if you struggled with that, I strongly encourage that you go and review that topic before you begin this lesson. But now we need to understand, where is this bounded by? Now this is a positive sign polar graph, so this means that you're going to be bounded, this won't matter, right? So what we're going to look at is from 0 to pi. Now, the other thing you need to understand, something very helpful in these kinds of problems, is to recognize symmetry. You have to understand that the red portion that I've highlighted is the exact same as this green portion. You add them up, it's the same thing. So if you're talking about this blue graph right here, what you can do is you can opt for this two ways, whatever you feel more comfortable with, but I think it's a little bit more simpler to double this area. I'm saying look from 0 to pi over 2. We're going to set theta 1 equals 0 and theta 2 equal to pi over 2, and then you can just double that. And the reason that's going to be helpful is because we have this 1/2 outside, so you're going to double that, that goes away. So what you're going to end up having is alpha equals 2 times 1/2. I'm going to do this in that way, 0 to pi over 2, r squared d theta. So now what we have is we can just cross that out. And your new equation that we're going to use for the rest of this is going to become area equals from 0 to pi over 2, r squared. Now what is r? We have 6 sine theta. 6 sine theta squared d theta. From here on out, it's just basic integration that I'll go through with you here. So you have alpha equals 0 to pi over 2, 36 sine squared theta d theta. Now, it'll be helpful to take this out, so you're going to end up having A equals 36 from 0 to pi over 2 sine squared theta d theta. Now, you can approach this two ways. Sine squared sine squared theta is the same thing as sine theta. Take it out. You could do the whole power rule and trig integration thing, but what I'm going to do here is I'm going to go back to these two formulas that I wrote earlier. These are the trig identities that you probably learned in pre-calculus. If not, I strongly suggest that you review those, but this is going to be what I'm going to refer to in this video. You're going to now have a equals 36 from 0 to pi over 2, 1/2 of 1 minus cosine 2 theta d theta. And then you can bring this out. You're going to have a equals 18 from 0 to pi over 2, 1 minus cosine 2 theta d theta. Now what this becomes is 18. Now 1, if you integrate that, that's going to be theta, because when you take the derivative, that's just 1, minus sine 2 theta divided by 2 pi over 2, 0. And then from there on out, plug it in. A equals 18 pi over 2 minus, now sine of 2 times pi over 2, that's just sine of pi, all of that over 2. Now sine of pi is 0, so you can just put 0 there. And minus theta now is 0. Same, sine of 0 is still 0. So that's just going to be that. Cross all of that out. You end up having a equals 18 times pi over 2, so a equals 9 pi units squared. That's your answer. So remember, we're going to look over at these two functions, these two derivatives, and then you're going to go from there. Now, the next two problems is, you're going to have this formula. I'm going to write it right here. R equals 1 plus 2 cosine theta. You want to find the area of the inner loop. Now this is going to be a limacon where you have a equals 1 and b equals 2. Now when a is less than b, that's going to be a looped limacon. So what this is actually going to kind of look like, and I strongly suggest, now in these kinds of problems, when you get to something more creative like this, it's going to be very helpful for you to understand what this graph actually looks like. So if you look at a looped limacon, what that actually looks like is when you have a equals 1, this is a positive cosine, so it's going to, the a value of number 1 is there, number 2 is there. Now you're going to have a plus b, that's 3, and a minus b is negative 1. So your loop is actually going to go in 1. What that's going to look like is like that. Kind of like the Airbnb logo. But now what we're going to take a look at is I'm going to show you what the actual graph looks like. Okay, I'm going to just erase all that. This is what your graph looks like. So when you're finding the inner loop, it's going to be that. Okay, so all of that. Whoops. Okay. So what you're going to look at now is we're going to find what are the tangents at the pole, because that's how you're going to figure out what your theta 1 and theta 2 are. You're going to go 1 plus 2 cosine theta equals 0, 2 cosine theta equals negative 1, cosine theta equals negative 1/2. Now, for cosine theta to be negative 1/2, theta is going to need to be 2 pi over 3 and 4 pi over 3. So these are your two tangents at the pole, and what that means is that's going to be the place where it's going to loop back in. So 2 pi over 3, I'm not sure if you can see it, but that's 2 pi over 3. Whoops, that's a really bad line. And then that's 4 pi over 3. So that loop is basically saying that from 2 pi over 3 to 4 pi over 3, that's the area. So, same thing as earlier. You can approach this two different ways. Now, I strongly suggest you look at the symmetry here. If you think about it, that's symmetrical. This purple top region is the same as that bottom region. So what I can do is I can say, look, what's the halfway point between 2 pi over 3 and 4 pi over 3? It's pi, right? So if you want to integrate from 2 pi over 3 to pi and then double that, it's going to be the same thing. That's exactly what we're going to do. You're going to say a equals 1/2 from 2 pi over 3 to pi r squared d theta, and you're just going to double that, so times 2. And what that's going to be is now you're going to have a equals, now you cross that out, that's going to be a equals 2 pi over 3 to pi, 1 plus 2 cosine theta squared d theta. Okay, now you have that. So what you're going to want to do is expand it out with FOIL. A equals, I'm actually going to stop saying A equals because it's going to save me a lot of space. But I'm going to have, the area is now 2 pi over 3 to pi 1 plus 4 cosine theta plus 4 cosine squared theta d theta. Okay, now what we're going to need to do now is simplify this out. So we're going to go back to that formula I told you about earlier. That's going to be 2 pi over 3 to pi 1 plus 4 cosine theta plus 4 times 1 plus cosine 2 theta all over 2 d theta simplifies to 2 pi over 3 pi 1 plus 4 cosine theta plus 2 1 plus cosine 2 theta. Now you can keep going, and that's going to end up being, I'm going to come back here, A equals 2 pi over 3 pi 1 plus 4 cosine theta plus 2 cosine 2 theta d theta equals 2 pi over 3 to pi 3 plus 4 cosine theta plus 2 cosine 2 theta. Okay, so now what you have is, now we can integrate this. I'm going to do this in a different color to make it easier. So you're going to have 3 theta plus 4 sine theta plus sine 2 theta. Now this is going to be sine 2 theta over 2, but we have that by 2, so we're going to cross that out. Plus sine 2 theta, 2 pi over 3 to pi. Now, once you plug that all in, you're going to end up having pi minus 3 root 3 over 2, and a better answer to put that as is going to be 2 pi minus 3 root 3 over 2 units squared. I simplified all this plugging in because it's just going to save me a lot more space, but that's kind of the idea. So the key here is to first recognize what your symmetry is, because it's going to make your problem a lot easier. You could do the same thing by doing 2 pi over 3 to 4 pi over 3, but the reason I was able to simplify this is because once you get to pi, sine of 2 pi, and sine of pi, that's all 0, and then 2 pi over 3 is really what you're plugging in over there. So that just made this a lot easier. You're going to have like 3 pi plus 0 minus whatever that is, the 2 pi plus 4 and blah, 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 blah. So that just made that a lot easier. You get to the same answer, but it's just a lot easier if you're able to recognize this, because a lot of the times it's going to be something like pi over 2 or pi, and then you can just simplify that and make it a lot easier for yourself. And now the key here was recognizing, first plugging in and finding what your 2 theta values were, and then going from there and figuring out, since these are your tangents at the pole, that's going to be where your looped limacon is. Okay, so now we're going to do one more. Now this is kind of an interesting problem, and this is going to be where, I said earlier that graphing helps. This is going to be where graphing actually really helps. So your first equation is going to be r equals 4 sine 2 theta. Actually, I'm going to do this in a clearer font. There we go. Okay. R equals 4 sine 2 theta. So this is those pedal curves. And then your next one is going to be r equals 2. Now, this is a circle, and if you aren't familiar with that, that basically is what that is, because this is going to be r squared equals 4, same thing as that. If you aren't familiar with that, I strongly suggest you go back to a polar review, because this is going to be something that you will definitely come across. So what this kind of looks like is, I'm going to graph this over here. So a pedal curve is going to be, let's make this r, or the blue one, and this is going to be the blue one. Okay, so this is going to be, since it's sine and it's an even number in here, that means we're going to double this. So you're going to have sine means that it's going to be halfway between 0 and pi over 2 is 45 degrees. So that's what that 2 is going to tell us, is that it's going to start at the 45 degree. And you're going to have 4 of these pedals. Whoops. It's not the best drawing, but that's the idea. You can kind of just say that, like, this is 4-ish. -4, 4, -4. And then your circle, this is going to mean that the radius, in the circle formula, this means that your radius is square root of 4, so radius is 2. So now you're going to have 2, -2, -2. That's your curve. I'm going to remove the numbers just for the sake of looking at it. That's your somewhat what your curve is going to look like. So before we start, I'm gonna set them equal to each other, because what we're going to solve in this problem is the regions that they are equal to each other. If you want to look at it, it's going to be kind of like that, so on and so forth. So set them equal to each other. You're going to say 4 sine 2 theta. Where is that equal to 2? So that's going to mean sine 2 theta equals 1/2, where sine is equal to 1/2 at your pi over 6s. So you're going to say that 2 theta should be pi over 6 and 5 pi over 6, which means that theta is going to be pi over 12 and 5 pi over 12. So, we're often, like, we look at our graphs in terms of pi over 6s, but if this is pi over 6, sort of, then that's going to be pi over 12. That's what we're saying. Or if it's easier, this is what we're saying. This is the pi over 12 point where they intersect, and that's the 5 pi over 12 point where they intersect. And 6 pi over 12 is pi over 2, so that makes sense. And then, obviously, pi over 12, go back, 0 pi over 12, that's just 0. So that's kind of what your graph looks like. Now, if I were to draw a line, let's take a little dotted line. That's our line going through each of these. Now, when you draw this line, you're going to notice that they kind of split up the curves now. Because now what we have is we have this blue region is of our circle. Whoops, I'm going to do that better. This is the blue region of our circle. And then this is the red region of our flower curve. So that means that when we're going to solve, also I'm looking at just one petal right now. At the end, we'll just multiply that by 4 since all of these are equal to each other. Obviously not in my drawing, but in real life. But that's what that means. So I've gotten a picture of it better over here. Whoops. Let me move that aside. So this is what we're looking at now. So this going back to this is our pi over 12 line, if you see. Whoops. Whoa. What's going on? This is our pi over 12 point. That's where they intersect. And that's our 5 pi over 12 point. Okay. So this is basically saying that the region at 5 pi over 12, this rose curve actually like goes below it, below the circle. And then our circle is going to be over here. Whoa, let's do that bigger. That's our circle. Okay, so what we're basically saying now is what we're going to need to find is where the area is actually going to be 3 separate integrals. And I know that sounds kind of overwhelming, but we'll split it up. So this is area 1. Whoa, this is area 1. This is area 2. And we're going to make this area 3. So let's set up the integrals first. Okay. I'm going to have area 1. I'm going to do this smaller. Area 1 is going to be the integral from 0 to pi over 12. And this is going to be not of the circle, because we're not looking at the circle. Because if you think about it, when you look at it from 0 to pi over 12, if you get the circle, you're also going to get all of this. And we don't want that. We just want this red part. So that's going to be the circle for our 4 sine 2 theta. 4 sine 2 theta squared, obviously 1/2. Sorry, I forgot about that. D theta. I'm just going to set up all the integrals first. I'll leave that there. And then a of 2 is going to be 1/2 from pi over 12 to 5 pi over 12. Because now what we're looking at, if you get pi over 12 to 5 pi over 12 of this big curve, you're also going to get all of that. And we don't want that. We want this circle. That's going to be, that's just 2 squared d theta. And then a of 3, or a sub 3, I'll actually do that here because we're going to need some space. A sub 3 is equal to, why is it so big? Okay, area 3 is from 5 pi over 12, and where are we going up to? We want to go up to pi over 2 now, because that's how we're going to get this area only. All the way to pi over 2 of 4, sorry, 1/2. I'll do this in red to show you which curve it is. 1/2 4 sine 2 theta squared d theta. Okay, now this is going to be the fun integration part. I'll actually do a of 2 first, since that's fairly simple. A sub 2 is going to be 1/2. I'll just put theta 1, theta 2 to make it clearer. It's going to be, it's just 4 d theta. Same thing as a2 of 2, theta 1, theta 2, d theta. When you integrate that, it's going to be 2 times, what is that, just theta. So that's going to be theta 2 minus theta 1. You have 5 pi over 12 minus pi over 12, which is 2 times 4 pi over 12 is equal to pi over 3. So that is just 2 pi over 3 units squared. We can put that off of our list. Now, for this, if we figure out what the integral is for this, it's going to make this part a lot easier. So let's do that. Okay, I'm going to do this in black now because actually I'll do this in red. Okay. 1/2. That's a 4, by the way. I apologize. Theta, I'll do theta 1 and theta 2 again since it makes this look a lot cleaner, but we're going to have 16 sine squared 2 theta d theta. It's going to be 8 theta 1, theta 2 of sine squared 2 theta. Now, if you recall, we know what it's going to be for sine theta. That's going to be going to be 1 minus cosine. Now, if you have it for sine squared theta, that's going to make it cosine 2 theta. If you have it for sine squared 2 theta, that's going to make this cosine 4 theta all over 2 d theta. If you take the 1/2 out, you're going to have 4 theta 1, theta 2, 1 minus cosine 4 theta d theta equals, here, I'll do that here. This is going to become, when you have 1 minus cosine 4 theta, if we do that, it's going to be 4 on the outside of theta minus sine 4 theta all over 4 from, what is our angle? We have from 0 to pi over 12. Now let's plug this in. It's going to be 4 pi over 12 minus, now sine of 4 times pi over 12 is going to be sine of pi over 3. Now what's sine pi over 3? That is root 3 over 2. Now you're dividing that by 4, so that's going to be root 3 over 8, right? So that is the first part, minus 0 minus sine of 4 theta is just 0, so you can ignore that. And that's going to be 4 times pi over 12 minus root 3 over 8. When you simplify that, you get pi over 3 minus root 3 over 2. So that is our area 1. Now area 2, you could go through all of this again, but I don't see a reason to, so I'm going to just get back to, where did we have it? We had it right here. That's what I'm going to do. You're going to have 4 times theta minus sine 4 theta over 4 from 5 pi over 12 to pi over 2. You plug that in. A sub 3 equals 4 pi over 2. Now sine of 4 theta, that is just 0, right? Yes, sine of 4 theta times making theta pi over 2 is just 0, minus 5 pi over 12. Now we had sine pi over 3, sine pi over 3 is root 3 over 2, minus root 3 over 8. Okay. Pi over 2 minus 5 pi over 12 plus root 3 over 8 equals, this is 6 pi over 12 minus 5 pi over 12 is pi over 12 plus root 3 over 8. That's the same thing as saying pi over 12 plus root 3 over 8. And then you have that equals pi over 3 plus root 3 over 2. I think I'm missing something. Minus root 3 over 2, 4 pi theta. Oh, I see what I did. Oh, sorry. 4 times 5 pi over 12 for the sign, going back here. That's actually 5 pi over 3. If you think about the unit circle, if you go 5 pi over 3, you're going to have a negative sign value. So I'm going to change that to positive. That is going to be negative. Whoops. Negative. Negative. Okay. So that's your a sub 3. So when you're solving for one petal, this is all for one petal, by the way, don't forget that. So one petal is going to be a1 plus a2 plus a3. That is, you had a1 is pi over 3. I'll make this smaller. Okay. Pi over 3 minus root 3 over 2 plus 2 pi over 3 plus pi over 3 minus root 3 over 2. Now, this is basically doubling it, so you're going to have 2 pi over 3 minus root 3 plus 2 pi over 3, which equals 4 pi over 3 minus root 3. Now, for 4 petals, multiply that by 4, so your total area is equal to 4 times 4 pi over 3 minus root 3 units squared. That is your answer. So, reviewing this one, more than the other ones, I think that it's very important to do this, because what a lot of people will do, I myself included, is what you're going to do is you're going to see this part, and you're going to find your two thetas, and you're just going to set theta 1 to theta 2, and you're going to make it the circle. Obviously, it can't be this one, but you're going to make it the circle, and then you're just going to solve for that. That is not, and then you multiply that by 4, you get 8 pi over 3. That's not anywhere close to this. So it's very important to make sure that when you're doing this, you account for everything, and then when you graph it, I mean, even though my graph here wasn't exactly the cleanest, you're going to notice that it's not the same. So I hope this video was helpful. Looking back here, I also highly recommend looking over these two integration techniques, because it's going to make it a lot easier than doing trig and then power rule. But always remember, these are your two go-tos when you're solving in polar area.